All right, in this video, we're going to look at summarizing data. There is a lot of information in this section, and this is probably one of the more important topics because when it comes to like a statistical investigation, we usually talk about everything that is in this section. So things like the mean, the median, the range, the interquartile range, stuff like outliers, etc., etc. So a standard deviation. So it's very important that you understand everything in this section. Okay, so some things you've probably heard of before, some things will be new, and it's extremely important that these things are in your bound reference and that you complete the notes. Okay, I'm not going to read through all of this because I'm sure you can read. So we're going to start off with the measures of center. Okay, so measures of center is basically with statistics, you can use usually just the mean or the median. We don't tend to use the mode as much when talking about statistics. So the mean, and for now, this is just getting your head around the difference of when you would use the mean over the median. So the mean we usually use for symmetrical data. So where we call it's normally distributed, that sort of stuff you won't see or hear about until year 12. But basically, we don't have any extreme values. So, there's just as many low values at the lower end as there is on the higher end. But basically, things are symmetrical. So if you think about the heights of people in year 11, heights of girls in year 11 at Shelford, you've got as many short girls as you do tall girls, but the majority of you would be about the same height. Okay, so that would be kind of symmetrical. The heights would be symmetrical, and you would take the mean. Now, when we use the median is when they're not symmetrical. So we have extreme values or, there's either really high values or really low values. Not everything is kind of the same. So let's just say if we were to take the age of people inside the classroom, and so the majority of you are 16 or 17 or maybe even 15. But if I was in there at 37, I would be an extreme value, an outlier, and then add in some more teachers, maybe I'm going to get in trouble here if I start thinking of people's ages, but you've got some older teachers, so like Mr. Souza, Mr. Mortimer, they're a little bit older, so they would make that classroom of people, not just students, but teachers as well, it wouldn't be symmetrical. Okay, you'd have the students and then you'd have the graph go up where the teachers are. Now, a good example of when you use the median is with house prices. So if you ever hear the media talk about house prices, they always talk about the median house price. And I like to talk about the suburbs that I live in because I live down, I'm currently in Mordialloc. So Mordialloc, the house price, let's say, is averaging around 1.5 million. But if you were to buy a house on the beach, then you're up for millions of dollars. So you've got your average, house price that's not near the beach, but because there are houses on the beach and you're paying for that view, they do go up. But you also have houses that are, really old, and then you've got houses that are brand new. So there's a huge difference in price. So you don't really have the house prices are about the same. So we always talk about the median house price. So that's something I like to think about when describing the definition of median. And also in Caulfield, you've got a lot of older houses, maybe houses on small blocks of land, and then you've got really big houses on big blocks of land. And so the difference in prices in those houses is quite extreme. Anyway, I'm sure you get the hang of that. So let's move on. Okay, so the mean. This is how we calculate the mean. We add up all our data values and divide it by the total number of data values. So let's say I was taking the height of you students in the class, not me included. I would add your heights all together. There are 14 of you. So I divide it by 14. Okay, so you've been exposed to the mean for a long time now, nothing new to you. Now, there's a formula down the bottom here. You don't have to be too familiar with it. When I saw it, I'm like, oh, this is just going to stress girls out. They're like, what are these symbols? Okay, so first of all, and it's written up here. Okay, we call this X bar. So there's like a bar on top of the X. That's just a symbol for mean. If you're doing methods, there's another symbol, which you, oh gosh, you're testing my memory. I think it's mu. But in general, we're just using X bar. Okay, so if you saw X bar, that just means the mean. Okay, this symbol here that looks like a funny E is just the sum of. Okay, so it's written here, the sum of. Oops, I don't think let's just see, oh, my pen's not working for me. Anyway, so it just means the sum of. X, so is just your data values. So the sum of all your data values, and then N is how many data values you have. Okay, so that's all written here. It's important to have that in your bound reference, but oh my gosh, you never really see it. So don't be too stressed about that. Okay, let's move on. All right, and you can do this on your calculator. My son, who's in year 7, has just been doing this by hand, and I feel like getting out my CAS calculator and saying, you can do it on here, but they don't have CAS calculators in year 7. So lucky for you, you can do it all on CAS. So we've got a set of data. So football teams, how many premierships they've won up until 2010. Okay, so you can see there. I'm going to do the examples in a sec because I want to move on and just talk about the median. Okay, so remember the median, which you've seen before, you've seen it probably since year 7, is your middle value. Now you need to take the middle value when it's in order from lowest to highest. If it's not in order from lowest to highest, there's no point in doing it. So you can see here our data set is going from 2 to 11, everything's in order. And we've got another one here, 2 to 11. So the only difference between the two, I think we've added in another 11. Okay, so that's important to know. So this first data set, okay, we have an odd number of values. Okay, so let me just quickly count how many we've got. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 values. So that just makes things easier to find the middle value. So you can see your middle value here, and we have 5 values on each side. Okay, so there's a clear median. This second example, we have 12 values. So that just means your middle value has to be between your two middle numbers. And to find what that is, you add them together. So 6 plus 7 and then divide by 2. Or sometimes it's pretty straightforward. You can just say, well, what is halfway between 6 and 7? It's 6.5. So if we just scroll down, it says that here. Okay, so when we go back to doing the example, we can have a look at that in a sec. So what I've just explained is in those 3 dot points. Okay, measures of spread. Okay, so the measures of spread, we can use the range or the interquartile range. So we'll do the range first. The measures of spread just is good because it tells us how much things differ. I'm just trying to think. Let's just say you're comparing two classes on their maths test results. So you might have one class where the highest number was 95% and the lowest number was 85%. So they would have a range of 10. And you'd say, oh, well, the majority of those students were quite close to each other. Whereas in the second class, maybe the lowest score was 50% and the highest score was 100%. So they had a range of 50. And then you'd say, well, there's a huge difference in the scores in that class. So the range kind of helps us compare two groups. Okay, and there's the range. Take the largest data value, subtract the smallest data value. Okay, I'm not going to do that example just yet. Okay, so the other, what do we call it? Measure of spread is the interquartile range. Okay, so you have the range and the interquartile range. So that is the middle 50% of data values. Okay, so you have what we call quartiles. So you're basically breaking up your data into 4 quarters. And your interquartile range, when you think if you're splitting something into quarters, you've got 4 lots of 25%. So your interquartile range is your middle 50%. And that's sometimes a bit easier to explain, showing you an example of how to do that. So there are the steps there. Okay, I'm just going to skip to the standard deviation. When I saw this formula, I was like, we never use it. And I don't even, actually, do you know what? I remember when I was in high school doing this formula, and I think that's the only time I've used it, and that was a long time ago. And it's still in the course, and it's a bit crazy. Why? A bit crazy. I don't understand why. But sometimes it's a good idea to know where things come from. So even though your calculator does it, there is a formula behind it. The calculator just doesn't spit out random numbers. It actually works to some formula. So the standard deviation tells us how far away values are from the mean. Okay, so that kind of gives us an indication of the range or the spread of the data. So a small standard deviation means most values are close to the mean. So when that maths example I gave before, that first class, the majority of students would be close to the mean, whereas the other class, they would be further away. So they would have a larger standard deviation. So this formula here, again, the symbols are the same as before. You've got the sum of the data value minus the mean squared divided by the number of data values minus 1. Okay, so don't be too concerned about that. I don't know whether your textbook uses it or not. Okay, so your instructions for CAS are here. What I'm going to do is I'm going to stop this video just so it's not too long, and I'm going to come back and do all the questions, and I'm going to do them with the CAS calculator. So even though the instructions are there, I'm going to do the questions again with the CAS calculator. Okay, bye.